Hello everyone, I am Dr. Abdul Shukur. In this class, we are going to learn how to solve NEET and JEE problems from friction. If you go through the PYQs, you can find a lot of problems from the friction, uh, and it is one of the very important topic from the laws of motion too. Okay, so in this class my aim is to clarify your concept related to friction, and also I will teach you how to solve the problems, and also we will go for a few NEET and JEE PYQs. Okay, so let me explain what is friction means. This is husband and this, uh, there is very good emotional bonding between them. They don't want to separate each other. Now, if someone try to separate them, they act an opposite force against that separation, and that force is actually frictional force. So we can find that friction. This is not a textbook definition. This definition I have written here to clear your concept. Friction is actually the force against the separation. I will explain it. Imagine someone want to separate the husband and wife. Imagine the sister-in-law want to separate the husband and wife. So sister-in-law uh, trying his brother separating his brother in this direction, means moving in this direction. So what wife do? You can see there is a very good bonding between them. So has the wife act a force in the opposite direction. So this is applied friction act in the opposite direction. Frictional force act in the opposite direction. Now imagine some neighboring auntie want to separate this girl from her husband. So the auntie applying force in this direction on the wife. So the husband act a force on his wife in this direction. So the force against the separation is called a frictional force. Now let me discuss in somewhat detail. Here imagine this is an almirah, and I am pushing this almirah in this direction. So this surface, you can see that here this is here this surface, here, this is the conducting surface here. The lower body don't want this almirah move in that because they don't want to separate each other. So this the lower body act a frictional force in this direction. So imagine I am applying a 100 Newton force, but almirah is not moving. What it means? We know that when there is a net force on a body, imagine there is a net force on a body, we know that that is equal to mass deflection. So if there is a net force on this almirah, the almirah must have some acceleration. But almirah is not moving. I am using a 100 Newton force, but almirah is not moving. But it means that the applied force is cancelled by some other force. What is that other force which is cancelling the applied force? That is actually the force which act in the opposite direction of the applied force. So imagine I am applying 100 Newton in this direction, 100 Newton. I am friction of acting direction, same 100 Newton. They cancel each other. Imagine I am applying in this direction at 200. So friction in the opposite direction 200 still is not moving. So imagine I have applied 500 Newton in this direction. So friction acting in the opposite direction 500. Still net force is cancelled. No net force. So body is not moving. But imagine now I applied a 501 Newton, 501 in this direction. Now body start to move. Body have now some acceleration. So what happened here? Now here what happened means friction have a maximum limit, that if body is not moving, we call it a static friction. If applied force is always cancelled by the frictional force and body is not moving, we call it a static friction is acting on the body. Now this static friction have some maximum limit. The static friction cannot act beyond that maximum value. So if my applied force is greater than that maximum limit, then there will be some net force on the body and body start to move and body will have some acceleration. Okay, let me clarify this each and everything. Now what is the static friction? If we do not consider the friction, there is some net force acting on the body, but the static friction which is acting in the opposite direction of that force, cancelling it, means now the static friction is equal and opposite. So applied force is cancelled by the static friction, body is not moving, then the friction is called static friction. Now the maximum limit of that static friction is called limiting friction. In this case, body is just about the move. If applied force is equal to the limiting friction, the body is just start to move. Now if applied force is crossed the limiting friction value, means the maximum value of the static friction, what happened? Body start to move. In that case, the friction acting on the body is called kinetic friction. Okay, so now let me write the formula. Static friction is always equal to the applied force. If applied force is 100 Newton, the frictional force also 100 Newton. If applied force is 200 Newton, frictional force is also 200 Newton. So this happens up to the maximum value. And limiting friction is the static friction coefficient of static friction, normal force. Normal force we are going to discuss now. So limiting friction, the equation of limiting friction is the coefficient of static friction into normal force. So what is actually coefficient of friction? Coefficient of friction actually measure how difficult, how rough the surface is. Means how difficult we experience when we move a body on the surface. That is what the coefficient of friction represents. If coefficient of friction is very high, it will be very difficult to move a body on that surface. Okay, if imagine the surface is very smooth, we can easily move it, so the coefficient of friction will be very small. So that is the limiting friction is mu s into n. Now if the body start to move, then there will be the kinetic friction, then friction is equal to mu k into n. Mu k means that the coefficient of friction when there is a relative motion. Okay, sometime in the question they do not give you a separate mu s and mu k value, they just give you the value of mu. In that case, you imagine that you must assume that the mu k equal to mu s equal to mu k. And note one point here, my aim is to not explain the theory behind the friction. In that case, we have to draw the that graph, friction versus applied force graph. And I am not going to that all. Here my aim is to clear it, to make you able to solve the problem from the friction. Okay, so note this point. If applied force is less than that of the limiting friction, body do not move and acceleration of the body equal to 0. If applied force is equal to the limiting friction, means the maximum value of static friction, the body is just about the move. Now if the applied force is greater than that of the limiting friction, body start to move and body have some acceleration. Now how to calculate the friction? I already given you the formula. Now how to solve the problem from the friction? To solve problem from the friction, we must have two things is very important. One is to understand the direction of frictional force, and second is determining the how to calculate the normal force. If we know these both things, we can easily solve any problem the friction. So first I will teach you how to determine the direction of the friction. Look, this is this is a table, and on the table I placed a mass m in the first example, and here the indication. So now you tell me in which direction the friction will apply. If applied for this direction, imagine this table is wife and this mass is our husband. Wife don't want to separate from the husband, so wife apply force. If the body want to move in this direction, Why apply in the opposite direction? This will be the double friction. If body move, it will be a static, it is a kinetic friction. If body do not move, it will be a static friction. Now let me go to the second example. Look, here we have an inclined plane. Here we have an inclined plane, and the angle of this inclination is equal to theta, and a mass of m is placed on this inclined surface. Now look, the gravitational force is always vertically downward. This is the gravitational force, vertically downward. Now I am drawing a perpendicular to the surface in this direction, and then this also will be theta. That also will be theta. So this will be an adjacent component of mg. So that will be mg cos theta. And here in this direction, opposite component of mg means opposite component of theta will be equal to mg sin theta. You may already know these things from the vector calculus. So now look here. Here there is a force in this direction, g cos theta, that is a component of gravitational force. Due to that force, body try to move in this direction. So now imagine in which direction the friction act. Friction act against this relative motion. So frictional force will be in this direction. Friction act in opposite direction of mg sin theta. Okay, got it? Direction of friction. Now third example. Here we have a lorry, and here we put a mass m on the lorry, and lorry is moving at an acceleration a. So what this lorry want? Lorry want, imagine this mass is let this mass is our fridge or our washing machine, and they are carrying it. So now look, what is actually carrying this washing machine along with the lorry, or what is actually carrying this fridge along with this lorry? That is actually the frictional force. That is the frictional force on the surface. If lorry surface is very smooth, then you can see that this washing machine or this fridge slide in the back side. They fall in the back side. You can see it. Now, in which direction friction act? If lorry with but there must be some limit of the acceleration, means the limit of this acceleration. In that case, the frictional force also acts in the same direction. In the same direction. I will give another similar example. You can see that conveyor belt. When we go to the airport or in the railway station, you can see that we place our luggage on a conveyor belt, and our luggage move along with the conveyor belt. In that case, the friction act in the same direction of the motion of the conveyor belt. Okay, this is a similar example. Now look, here this is a bus, and here we place the mass m like this. You can, bus is moving in this direction, and since this is a mass m, a vertically downward gravitational force in this direction. So if there is no frictional force, imagine here there is a sufficient acceleration, means the bus is moving with a very high acceleration, then the body do not fall. So what is stopping from the falling? Downward there is a gravitational force. So when there is a gravitational force in the downward direction, body must fall. What is stopping this body from the falling? That is actually frictional force acting in this. Frictional force acting in this surface. So here friction acting in this direction. Okay, this will be the force. Another example. You can see these all examples in the previous NEET and JPY. Here look, this is a table. Here I place it M, and this mass M is connected to a pulley with a string with another. So you can see that M2 force means a gravitational force acts on M2G. So this pull this, then there will be a tension on the string direction. Okay. So this tension try to move this direction. So the friction in the surface will be act against that tension force that will in the direction. Okay. So understand this point. Friction always acts against the relative suppression or against the relative motion. In this way, you can easily find the direction of friction. Now, if you know how to calculate the normal force, we can solve any problem from the friction. Now, I will teach you how to calculate the normal force. You may have already learned the normal force, tension, the basic of these all things in the first or second class of the laws of motion. Now here my aim is to teach you how to calculate the normal force, not to teach you what is the normal force. You may already know that the normal force always, when there is a contact between the two surfaces, there will be a normal force, one surface act on the another surface, and which will be always perpendicular to that surface. So here the first example. In the first example, look, this is a table. I placed a mass m on this table. So you can see that a gravity always acts vertically downward. But this body is not moving vertically downward by breaking the table. And if this body is neither jumping in the upward direction, it means that some force which is cancelling the gravitational force. What is that force? That is the normal force by this table surface which is acting on the mass m in the direction of mg. So here in this case it will be equal to gravitational force. Now let us go to the next example. Here look, here other than gravitational force, one more force acting on this body in this direction, and imagine this force make an L t the whole. So here you can see that there is a two force acting on the body now. Now there is an applied force and there is a gravitational force. Gravitational force is downward. Applied force is in the make an angle theta with the horizontal. So this I have a component here f cos theta, this is a component f cos theta here, and in this direction f sin theta. And the surface act normal on this body, that also will be direction. Now look, net apply. Now this mass is neither moving downward by breaking the table, or neither the mass nor the mass moving in the upward direction. It means that net downward force is cancelled by the net upward force. So here net downward force is equal to mg, net upward force is plus f sin theta. Now you can find n from here. What will be n? Isn't it? So in this case also you can easily find the normal force. Now look at this one. Here other than gravitational force, no force acting on the body. There is no other external force acting on the body. Only gravitational force acting on the body. So gravitational force always act vertically downward. Now this gravitational force have a component in this direction, that will be equal to mg cos theta, and in this direction we have already learned that will be mg sin theta. Now look, if the body stay on this inclined surface, body is neither moving in the up direction nor moving the down direction, it means that this mg cos theta is cancelled by some other force. What is that force? That is here the normal force, that is the surface act on the body, that will be in this direction n. So here n is cancelling mg cos theta. So here n is equal to mg cos theta. Okay, got it? Now one more example. This is a wall. This is a wall, and here I placed a mass m, and I am pushing this with a force F. And now this body is not falling down. So look, now the normal force, the surface act a normal force in the opposite direction. It will be in the direction n. So here F will be n. Here normal force cancel the applied force. That is why if the normal force do not cancel the applied force, the mass break the wall and move in that direction, in the direction of applied force. If mass is not doing that, it means that applied force is cancelled by the normal force. So here normal force is equal to the applied force. Okay, so we have learned how to calculate how to determine the direction of friction, and also how to calculate the normal force. And now we know that limiting friction equal to S in n, and kinetic friction is equal to mu into n. If in a problem, if it is not mentioned mu s and mu k separately, the limiting friction, both limiting and kinetic friction will be equal to it is mu into n. Then it is equal to the friction force will be equal to mu into n. And static friction is always equal. If you know these things, you can solve any problem from the friction. Now we are going to solve some few PYQs from NEET and JEE. Okay. So the first problem is from the JEE 2024. So in this problem, consider a block and a trolley system as shown in the figure. If the coefficient of kinetic friction between the trolley and the surface is 0.04. So here mu is given, here mu equal to 0.04. The acceleration of the system. So here we have to find the acceleration of the system. Kinetic friction is given here. So acceleration of system is asked, and here you can see that in the option 1.2, 4, 3 and 2 is given. It means that there is no zero option. It means that body have some acceleration. Body have some non-zero acceleration. It means that body is moving. So the friction acting on the body is a kinetic friction. How to find the acceleration? We have to calculate the net force acting on the body. Net force acting on the body will be equal to applied force minus the frictional force. So net force is equal to total mass into acceleration. So related to friction, if any problems come related to the friction, what you have to do? You first check whether the applied force is less than that of the limiting friction. If it is less than that of the limiting friction, or if it is just equal to the limiting friction, body is just start. If it is less than that of the limiting friction, body do not move, then acceleration will be equal to 0. Okay. If it is just equal to the limiting friction, in that case also acceleration is equal to 0. You can say that body is just to start to move. And if applied force is greater than that of the limiting friction, then the body will move. Then in that case, you have to calculate the kinetic friction, and the net force will be equal to applied force minus the kinetic friction. So you can always make the to calculate the acceleration. You can write it is equal to minus F kinetic is equal to the total mass of all moving body, mass of all body into acceleration. So by just equating it, you can, by rearranging the terms, you can find the acceleration. So let us solve this problem. Okay. Here, what is applied force here? First, let us calculate applied force. 6 kilogram mass is here, and gravity is 60 Newton. So here you can see that there will be a tension here because it is a same string. You can see here this is a same string connected through this pulley. So here the tension force also will be equal to 60. So here the applied force is 60 Newton. Kinetic friction in this position that is given in the figure itself. Okay. Net force will be equal to 60 minus kinetic friction. So F net is equal to 6 minus friction, and we know that kinetic friction equal to K into N. U is equal to 0.04. So what is here N? This we already here. Here look, mass is equal to 20 kilogram. Downward force is equal to G. So upward normal we have what is this case, our first case, applied force is equal mg. Here normal force is equal to mg. So here N is equal to m into G. So m is 20 kg, G is 10 meter per second. So that is the normal force is equal to 200. Now applied force is Newton. The next we to 60 minus mu k is 0.04, isn't it? Okay, 0.04. 0.04 I can write as 400. So this 100 cancel. So we will get 60 minus 14 into 8. So this is equal to T Newton. So this is equal to 50 T Newton here. Now we have to calculate the acceleration to total mass of moving body. Total mass of moving body is here. So here 20 kilogram is moving and 6 kilogram is also moving. So total mass is equal to 26 kilogram. So total mass is 26 kilogram. So what will be the acceleration? It will be equal to net force upon total mass of the moving body, that's equal to 26. So 56 by 26 equal to 2 meter per second square. So which option is correct here? Option D is correct. 2 meter per second square is the answer. Now let me go to the next question. Next question is from NEET. This is I think a special examination conducted in the Manipur state. So this is a NEET 2023 question. Okay. So here look, we have a block and its mass is given. Its mass is given 2 kilogram. And is the coefficient of friction is given? Coefficient of friction is given 1.3. And acceleration of dvt due to that is given as 10 meter per second. So we can take it as a 10 meter per second. What here we have to calculate the net force on the block. Okay, we have to calculate the net force on the block. So already I told you that if when we place a mass on an inclined plane, acceleration due to gravity vertical downward mg, and in this direction mg cos theta, mg and sin theta. Here frictional force in this direction, we already done it. Friction in this direction. So look, and normal force is that. So here normal force will be equal to, we have already done, normal force is mg cos theta. So friction here, we don't know whether it is a static or kinetic. We have to calculate the maximum value because mu is given here. Based on that we calculate the friction. So friction here equal to friction here equal to 1 upon root 3 into n is equal to mg cos theta. M is given 2 kilogram, g is 10, theta is 30, you can see in the figure. So cos 30 is equal to root 3 by 2. So here frictional force 2 and 2 cancel, root 3 cancel. So here frictional force is 10. Frictional force is 10 Newton. Now let me calculate the mg sin theta also. If mg sin theta equal to 10 Newton, then there will be no motion. So the acceleration will be 0. What we have to calculate here, no need to calculate the acceleration. Only the applied force is asked here. Okay. So friction is 10 Newton. So net force on the body is asked. So let us calculate the mg sin theta. If mg sin theta is greater than friction, then there will be downward motion through that inclined surface. If mg sin theta is less than 10 Newton, it means that if mg sin theta is equal to 10 Newton, then there will be no net force acting on the body. Body do not move, acceleration will be 0. Okay, let me do it. So let's calculate the mg sin theta. M is sin theta equal to 10 sin. Sorry, m equal to 2 is here, not 2 kilogram is given. 10. M is equal to 2, g equal to 10, sin 30. Sin 30 equal to cancel 10 Newton. So m sin theta equal to 10. Friction is also 10, and you can see that they are acting in opposite direction, so that get cancel each other. So what will be the net force acting on the body? 0. So option B is correct. Let me go to the next question. Next question is from JE 2023, and in this problem we have as shown the figure, there is a mass of 10 kilogram lying on the horizontal surface, is pulled by a force F, but it is acted at 30 degree from the horizontal direction. With mu s is given 25. Here is given mu s, friction is given 0.25. Okay. The block will just start to move for the value of F. We want to find what is the value of F. In that value, the body is just about the move. It means that we have to calculate the limiting friction and make it, and we have to equate that with the horizontal component of this force. Okay. This force have two components. In this horizontal component, we have cos 30. F sin 30. I am looking at this block. Okay, that will be better. So here we have a block. What is its mass is given here? 10 kilogram. 10 kilogram block. And here F direction F cos 30. In this direction F sin F, and force from the surface direction N, And here also I told you that body is neither moving in the downward direction, neither body is moving in the upward direction. It means body is if applied force is, if there is a sufficient force, body may be moved in the horizontal direction. Okay, so body is neither moving in the upward nor moving in the downward. It means that applied force is cancelled by the downward force. So sorry, net force is net force is downward force. So n is equal to mg minus f sin. Everything given here. We can calculate the n. So n is here mg minus f sin theta. M is given 10 kilogram. Okay, 10 g. So f not given. So f is equal to sin 30. Sin 30 is equal to 1 by 2. So n is equal to 100 minus n is equal to minus by 2. So here let us calculate the friction on this body. Friction is equal to mu n. Mu is given. Mu is here 0.25, isn't it? Yes, sir. So mu is here 0.25. I can write it as 1 by 4. 1 by 4. 0.25 equal to 1 by 4. So the maximum value limiting friction will be equal to mu into n. So 1 by 4 into 1 by 4 into 100 minus. This here this is here the limiting friction. If f cos theta equal f cos theta applying the friction in the opposite direction. If f cos theta equal to the limiting value, maximum value of static friction, the body is just about to move. We want to find that value. The block will just move. We want to find that value. Okay. So I equate f cos theta equal to the f cos theta equal to limiting value of the friction. So I'm writing here. Okay. F cos theta, f into cos 30. So I can write f into by cos 30 equals to 1 by 4 into 100 minus f by 2. Now look, only f is unknown value here. You can rearrange the term and you can calculate it. Okay. So here there is no enough place, otherwise I will do it. So let me rearrange it. I am taking the f in the one side and look the 4 here. So 4 by 4 in root 3 by 2 to 100 by 2. Okay. Now take this f by 2 in the left hand side. So 2 root 3. 4 by 2 equal to 2 root f plus by 2 100. Now this is equal to 4 to 3 plus 1 by 2 f. Now I can f will now multiply, so you will get f equal to 200 divided by 4 root 3 plus 1. This is root 3 equal to 1.73. So this is equal to 200 upon 4 root 3 plus 1. This is equal to 25 point. Okay, 25.2. So which option is correct here? 25 point. Option A is correct. Option A is correct here. 25.2. Okay. Now let me go to the next question. Next question is from AIPMT 2024. A system consists of 3 masses M1, 3 masses M1, M3 connected by a string of mass pulley P. The mass M1 hangs freely, and M2 and M3 are on a rough horizontal. The coefficient of friction is mu. The pulley is frictionless, negligible mass. The download acceleration of M1 is. So here I assume that M2 and M3 is M. So here it is asked downward acceleration of M1. Now imagine if this M1 is moving downward with an acceleration A, M2 and M3 also move with the same acceleration in this direction because they all are connected by same string. Okay. So now we want to calculate this acceleration. So I told you that how to calculate the acceleration. We calculate the net force, and so the net force will be equal to the mass of all moving bodies into acceleration. Okay, so let us calculate the net force. Here in this direction, m1g, that will be equal to mg force is acting in this direction. Okay, now this is connected with this string, and this string is connected through the pulley. So here in this direction there will be a tension T that acting on m1, m2. What will be that tension? Tension here, tension will do m into g. M1g equal to m into g, because it is given that m1 equal to m2 equal to m3 equal to m. So tension equal to m. So a tension force acting in this direction. Okay. Now that is equal to mg. Now look here, against this pulling force there will be a frictional force in this direction on m in this direction, and also on m3 in this direction. So on m2 it will be equal to mu into m2g. Mu into m2g. The frictional force will be equal to the normal on m2 will be in this direction m2g. Here also normal in this direction m2g, and the coefficient of friction is given mu. So here the friction will be equal to mu into m. Here also mu into m. So look, in this direction mg force, tension, mg force, in the opposite direction mu into mg, mu into mg force is acting. So the net force will be equal to mg minus mu mg plus mu mg. So this will be equal to m into g minus 2 mu g. M into g minus 2 mu m. So mg is common here. So mg into 1 minus 2. So this is force net force acting on in this system. Now what is the total mass of the moving body? All three, if m1 move, m2 and m3 is connected with the same string, so the all these bodies move. Total mass of the all moving bodies is equal to m1 plus m3, because this is all m. So total mass of the total mass is equal to 3m. So net force equal to total mass of the moving bodies into A. So mg into 1 minus 2 equal to 3m in A. We want to find the acceleration, and m get cancelled. So A will be equal to g by 3 into 1 minus 2. The second option is the g by 3 into 1 minus 2 mu. G by 3 into 1 minus 2 mu. Option C. So here option C is correct answer. Okay. Now let's go to the another JEE main question. Here two masses, m1 equal to 5 kg and m2 is 10 kg, connected by an inextensible string over a frictionless pulley, are moving as shown in the figure. The coefficient of friction is given 0.15. The minimum weight m that should be put on m2 to stop the motion. Look, if you read the question, it may be look very difficult, but we can easily solve this. Okay, if you understood the concept of friction, we can easily solve it. So here look, in this direction mg force is m1g force acting, m1g, and so this m1g actually pull this string, it pull in this direction, pull this m and m2 in this direction. So if what is the question? To stop this motion. So if the frictional force in this direction is equal to this m1g, then they stop the motion, because they cancel each other, there will be no more motion. So what will be the frictional force? Mu into m in upward, in the downward there is gravitational force, m plus m2 into g. So that will be equal to the normal force. So here the normal force is m plus 2 g. Friction will be equal to mu into m plus m2g. If this frictional force is equal to m1g, then there will be no motion. So if m1g equal to mu into m plus m2g, there will be no motion. What is here? What is the question is asked? The value of m, so that it can stop the motion. If we replace the m, this m1g push this m2 and they move. If you place m, there will be no motion. M1 the m1g cancelled by the frictional force on the surface. Okay, so we can equate m1g equal to mu into m plus m2 into g. So here look, m1 everything is given here. What is it? M1 is 5 and g we can cancel. G value is not given. Sometimes we take it as a 10. Imagine if it is not given, sometimes we take it 9.8. By looking at the options you can decide it. So here no need to give the value because g get cancelled. So m1 is given 5. Given 0.15. Okay. 0.5 is not given. That's what we have to find. M2 is given. What is M2 here? M2 is given 10 kilogram. So 10. So 5 equal to 0.15 into 10. So we can this will be equal to 5 equal to 1 m 0.15 into 10, or we can write 5 minus 0.15 into 10 equal to 1.5. 1.5 minus 0.15. So this is equal to 3.5. 3.5 equal to 0.15, or we can 3.5 upon 0.5. So this we can write 3.5 we can write 350 by 10. Okay, 350 we can write this 35 by 10. 35 by 10. And 0.15 we can write as a 15 by 100. 15 by 100 numerator. Okay. So this will be equal to 350 by 15. If you calculate, you will get it 20. So which one is correct? 23.3. Option C is correct here. Now we're going to solve one more problem from the JEE main. Maybe if you read this question, you may feel it is very difficult, but it is very easy to solve. So here look, let me read the question. In the given arrangement of doubly inclined plane, two blocks of mass capital M and small m are placed. The blocks are connected by a light string passing over an ideal pulley as shown. The coefficient of friction between the surface and the plane is given 125, and the value of m for which capital M is equal to given 10 kilogram, for which the body, the capital M, moved downward in the down with acceleration 2 meter per second. Acceleration is 10 meter per second square at 15 due to gravity. Here 3753 degree is given. So maybe you already know that. If you make a right angle triangle, and 53. Opposite against 37, the length will be 3. Against 53, length is 4. Will be 5. Okay, so you can easily find sin 37, cos 37, sin 53, cos 53 because every side is given. Now let us solve this. So here look, in this direction I am drawing it. Look, let me expand. In mg sin 50. In this direction mg sin. Okay. Now this is the force due to the gravity. This is the component of gravitational force. Now let us calculate the friction also. Here in this direction frictional force that will be equal to, here normal is, I know already told you that this is mg cos 53, cos 53 in this direction mg sin 53, sorry mg cos 37. So here in this direction mg cos 53, here normal mg sin the capital M here, and cos 37 normal force. So the friction angle, look, the friction force on the surface action. So in this surface also it acts because mg sin 53 is pulling it in this direction. So friction on this will be action. So look, there is one pulling force that is equal to mg sin 53. And to stop this motion, there is three forces acting. One is friction in this direction, another is friction, another three forces. So we can write now the net force on this system will be equal to mg, net force on this system will be equal to mg sin 53, that is in the stopping force, and what is stopping minus here capital Mg cos 53, sorry mu in that is normal, and so friction will be here in this mu into capital Mg cos 53. So mu capital Mg cos 53, here 2 force mu small mg sin 53 is cos 37, here the angle is 37, cos 37, then one more plus and okay. Substitute all values and rearrange the term, we will get the values of m. Okay, here the acceleration is given, so this is the first I will write the net force, and the net force is equal to total mass of the moving bodies into acceleration. Here the acceleration is asked, so let us calculate the net force. Substitute the all values. This is a capital M. So capital M is given 10 and G is sin 53. Sin 53 look opposite side 4, hypotenuse 5, 4 by 5 minus mu is given 0.25, so 1 by 4. I am taking this, so that you can cancel 1 by 4, capital M 10, 53 means 3 by 5, adjacent side of 53 3 and upwardness 5, so 3 by 5 into 3 by 5, so mu 1 by 4 again, by 4 means that what value we have to find, and G is 10 and cos 37 equal to 4 by 5 plus mg sin 37 plus mg, m equal not given, small m is not given, G equal to 10 37, sin 37 equal to 3 by 5, 10 into 10 10 into 10 100 into 4, 400 by 5 equal to 80 minus here 10 into 100 into 3 300 by 20, 300 by 20 equals to 8. Okay, in the 20 5 times, sorry 15, 5 times in 100, so 300, there is 15 times, not 8 to 15. Plus here 1 by 4, here look at 10 into 4 40, 40 by 20 equal to 2, so plus 2. Here you look at 30 by 5 equal to 6, so plus 7. So 80 minus 15 plus 8, 60 minus 50 equal to 65. So 65 minus 8 m, this is net force. So to calculate the acceleration, what I told you that we have to equate net force equal to total mass of the moving body into acceleration. So net force is equal to 65 minus equal to the moving body, capital M and small m into L. So 65 minus 8 m equals to m is given 10. 10 small m we do not know, that what we have to calculate is, so 10 MA. We have to calculate the value of small m. A is given 2. Okay, so this will be equal to 65 minus 8m equals plus m into, my pen is tired, it is not properly right. Okay, so 65, here 2 into 10, 20, so 60 minus 20, here m into 2, this is taking here, so become 8. So 65 minus 20 equal to 45, so 45 equal to 10, so m will be to 45 equal to 45. So capital M is 10, small m is 4.5, the system move at an acceleration of 2 meter per second square. Okay, that is what asked in this question. So option A is correct here. Okay, so now I'm just going to conclude. The frictional force act always against the relative motion. Okay, note that point. If applied force is less than that of the limiting value of the static friction, the acceleration of the system will be equal to 0. If applied force is greater than the friction, limiting value of the friction, then to find the acceleration, what you have to do? Applied force minus kinetic friction equals to total mass of the moving bodies into acceleration. You substitute the values in this equation, you can find the acceleration. Sometimes mass will be asked, just like in this question. Substitute the values, rearrange the term, you will get the mass or acceleration. Whatever it is asked, you can find it. Okay, so this class is over. If you people have any doubt, you can just comment here. I will explain it. Okay, thank you everyone.